do this piece, okay? Example 2, state the transformations, then graph. Okay. Notice how this has a fraction right here. The first thing I'm going to do is rewrite it to where my x term is in the front, so 1 over x plus 3. Okay, okay. So anytime you see the transformations, you're going to have to graph that in stages. So the first piece is going to be your parent. Your parent function is y equals 1 over x. Now, if you are graphing, you do need to find your asymptotes, okay? So your VA, oops, which you can't see. Your VA is whatever the denominator cannot be. So the denominator can never ever be 0. So this is your VA. Okay. The degree on the top is 0, because there's no x term. Okay, so let's look at this. Degree is 0 divided by the degree on the bottom is 1. So, and because it's not an improper, we are going to have an HA. And to have an HA, we need to start with y equals. Well, as x gets really, really large, 1 divided by a really large number, it's also approaching 0. So in this case, we have y equals to 0 for HA and x equals to 0 for vertical. And yes, you have to graph those out using dotted or dashed line. So please use a different color to demonstrate your VA and HA. This is a vertical, so we are going to write x equals to 0 and label each one. This is your horizontal, and label this as a y equals to 0. Because you have one VA, you are going to have 2 curves, okay? Let me spell this out for you. 1 VA equals 2 curves. Okay. One on the left side of the VA and one on the right side of the VA. So here's the work. Right side and left side. And make a T-chart. So let's pick some values. Input, output, input, output. Okay. The first one I'm going to pick is obviously, can I pick 0 for x? No, because you said, hey, your vertical is already at 0. That means x can never be 0, so you can't pick 0. But you can put the right-hand side is over here, so we can pick 1. Okay. So we're going to go, hey, the parent function, 1 divided by 1, 1 divided by 1 is 1. Okay. Let me zoom in. Right there. Okay. Then I'm going to pick the largest value I can pick for this grid, which is 10. Right. Then I'm going to go, hey, 1 divided by 10 is simply 1/10 because I can't reduce. Then I'm going to pick a very small value, as close as I get to the vertical asymptote, which is 1 over 10. So over here, 1 divided by 1/10. So let's check it out. 1 divided by 1 over 10, which is really 1 times the reciprocal, which is 10 over 1, which is really 10. Not cool? So I have 3 points, and yes, minimum 3 points is required. The first one is 1, 1, which is right here. See how awesome that is? Okay. The second one is 10, 1/10. This is a 10 by 10, so you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1/10, that means not quite 0 yet, okay, but is pretty darn close to 0. So put a dot as close to the asymptote as you can. Just try not to touch it. Then over here, 1/10, when the input is 1/10, the output is 10. So it's right over here somewhere. And again, try not to touch your vertical or horizontal asymptote at this point, but get as close as you can. So that's the right curve. Okay. Now go and fill that in so that way it looks like it's on the curve itself. Now we are going to do exactly the same thing. On the left hand side of this vertical asymptote, we are going to pick -1 and a very small value, which is as -10, and a value that's super close to 0, which is negative 1/10, just on the left-hand side of your vertical asymptote. You will always have one on the right-hand side of the vertical asymptote and one on the left-hand side of vertical asymptote. So 1 divided by input negative 1, which is negative 1. Plot that. So negative 1 divided by, okay, so negative 1, negative 1. Then we have 1 divided by negative 10, which is negative 1 over 10. So when I have negative 10, I'm down here very close to 0, right? Because negative 1/10 is super small. So try to make a dot. I know it's really difficult to make a dot that's not touching the asymptote, but try your best. All right. Then I have a very small input value, okay, so small that it's very close to this asymptote. But when I divide it, 1 divided by negative 1 over 10, which is change the sign to multiply and take multiply by its reciprocal. The reciprocal of negative 1/10 is 10th, so this is really ending up as negative 10. So when x is super small as 1/10, y is a negative 10, which is all the way down here. Okay, so now that I have 3 dots clearly plotted, okay, try to make your best to connect them. Okay. And again, make sure you are clearly showing that your graphs, your curves, the two curves do not touch the asymptotes at this point in time. The nice thing is you only have one transformation. Okay, so let me zoom back out so we can see. Okay. We only have one transformation, which is this plus 3 right here. So our equation is y equals 1/3. Oops, what am I doing? I mean 1 over x. My bad. Let me wipe that out. Alright, here we go. Here's a whiter. 1 over x plus 3. And this is state the transformation. So this is a up by 3 units. Okay. When you go up by 3 units, everything is going to move. Okay. So what that means is that your x values will stay exactly the same, okay? But your y value, so that means x will stay exactly the same, but the y value will add 3. This is what it means by up by 3 units, okay? So first thing, let's take care of this asymptote. Okay. This is a y equals. Well, y said it's going to change by 3, so now we need to move it up by 3. Okay. And now label it. Y equals to 3. It used to be a 0. We are moving things up by 3, so now it's currently 3. Now this asymptote, this vertical asymptote, notice how we're labeling it as x equals to 0? Well, x is not really moving, so this will stay as exactly where that is. Okay? So, left side and right side. Let's look at these. So I have my right side, okay, and I'm just going to write the order pairs this way. Oops, which is moving over. Can you see that? Let's zoom out a little bit. Okay, so the right side, remember, the x do not change. Notice how this, so I'm going to write 1. Okay, all of those coordinates are exactly the way it is, but the y values will. If the output used to be 1, 1 plus 3 is now 4. If the output used to be 1/10, 1/10 plus 3 is 3 and 1/10. If the output used to be 10, it is now 10 plus 3 is 13. That's just how we find the new points. Left. Okay. 3 points. Again, the inputs do not change according to my up by 3 units. So negative 1, negative 10, negative 1 over 10 will stay as is. Then negative 1 plus 3 is going to be a positive 2. Negative 1/10 plus 3, that's a positive 2 and 9/10. Negative 10 plus 3 is going to be a negative 7. So these are my points for this second graph, which is our final graph. And let's plot that really quickly. 1, 4, use 1, use 4. 10 and 3/10. I know this is a 10 by 10, so if I just go all the way over, and 3/10 slightly above my asymptote, because that's already 3. 1/10, which is super close to this vertical asymptote, and go all the way 13. If this is 10, I'm going to make 3 more tick marks. 10, 11, 12, 13. So I'm going to go whoop, all the way up there. Yes, it is okay to go beyond what's given to you. So connect those. Okay. Then the left hand side, -1, comma 2. Here's -1, comma +2 right there. Then we got -10. Here's -10. 2 and 9/10, which is not quite at 3. So we're going to put it right here. Then we have -1/10, which is super close to 0, and then -7. So I know this is a 10 by 10, so if I count backwards by 3, I should be okay. Okay. So this is the other curve. Okay, so this is the left side. So notice how the way that it looks, okay, from the parent should be very similar. It's just moving, stretching, compressing. Even though on here it doesn't say the domain and range, but as you know, I would always ask. So let's write the domain. Okay. The domain is, because VA is at 0, you know that the domain X can never be 0. They are totally related. The range, okay, notice, look at my final graph. The range is that Y can never touch my Y equals to 3, so the range is that Y can never be negative. I'm sorry, what am I saying? -3, +3, because I move up by 3. So, oops, can you see that? This is a +3. Ooh. Okay, so that's your domain, and that's your range, and let's wrap it up. So this is the end of today's video. Have a good one, and I will see you guys in class. Adios.